was on the other page, but the title I think is Equivalent Rational Expressions. Okay. So we say that two rational expressions are equivalent when their simplified forms are equal to one another. Okay? So just kind of like fractions, if you think about, I don't know, 6 over 8 and 75 over 100, right? These are equivalent because I can reduce this to 3/4, and I can reduce this to 3/4 as well. Therefore, these guys must be equal. Okay? Same sort of idea with rational expressions. If you want to know if two rational expressions are equivalent, we need to just simplify them and look at their simplified forms. Okay? So if we wanted to determine if the rational expressions 9 over 3x minus 1 and negative 18 over 6x minus 2 are equivalent, then we need to look at each rational expression and see if it has been simplified. And if it hasn't been simplified, we need to simplify it, and then we can do a comparison. Okay? So this first guy, can I simplify that? No, nothing to do there because this is just a 9 and the denominator is fully factored. Okay? What about the negative 18 over negative 6x plus 2? Yeah? Yeah, you can divide it by negative 2, or like, if you can see that, great. If not, the general process is factor, see if there's common factors, right? And there is a common factor in the denominator of negative 2. And then this would become a minus 1 because negative 2 times negative 1 is positive 2. Okay? Now, we can simplify negative 18 over negative 2 is what? Yeah, 9 over 1. So this becomes 9. Okay? Now, what can we say about this and this? Yeah. These are equivalent. Okay? This one was pretty straightforward. Okay? Sometimes these get a little bit more complicated, particularly if we do funny things with negative signs. So one thing that I actually recommend to people if you're unsure is you can sub in a value for x, sub in x equals 1 to both expressions, and see if you get the same number, right? So if you want to check through verification, you can do a substitution. So for example, and for this one, it's not that important because this is a pretty simply, or the second one was pretty simple to simplify. But if you're unsure, then you can plug in x equals a number, whatever it is, to both. So let's say I plug in x equals 1. Then what I'm going to get in the first expression is 9 over 3 times 1 minus 1, which is 9 over 2. Okay? In the second expression, I would go, okay, negative 18 over negative 6 times 1 plus 2. And that's negative 18 over negative 4, which is 9 over 2 as well. Okay? Now this doesn't prove, I mean, it's possible that you may just pick some lucky number where the two expressions are equivalent. But that's unlikely. So it's a good form of verification if you're unsure. Okay? All right. So I'm going to get you guys to try these two. And then we'll talk about a different type of question after, which is like a finding the mistake problem. So I'm going to pause the recording now, and then we will pick it back up in a couple of minutes. Okay, so the next type of problem that we're going to look at actually can come up in any unit. And it's one of these things where you need to try and find a mistake. And sometimes you just have to find the mistake. Usually if it's just find the mistake, it'll actually be a multiple choice question. And it'll maybe be 4 steps, and I'll be like, what step did the mistake happen, right? Or sometimes it's a written response question and you have to find it and then you have to correct it. So there are multiple ways about going about one of these questions. Some people really like to just look at the student's work and try and correct what they did. And other people like to just do it themselves first. Okay? So pick the strategy that makes you most successful, right? Sometimes when people look at student work like this, you can look at something and be like, okay, that kind of makes sense, I can follow, but there's actually a mistake in there. Whereas if you have to go through the process yourself first, then you know what's right and you can differentiate that from what's wrong. So whatever you want to do is fine. I'm going to just look at this and go through the process. So it looks like in the numerator there's a GCF of 2x squared. So I'm going to pull that out times 2x minus 9. And in the denominator, it looks like I've got a GCF of 2x. And I'm left with 3x minus 1. Okay? And then what I can do, it looks like in their work they have listed the non-permissible values at the very end. I like to do that at the beginning. Because sometimes if I cancel factors, I forget to write them in as non-permissible values. So I'm going to look at this and I'm going to say, okay, x cannot equal 0. And from here, I'd have 3x equals 1, x equals 1/3. So x cannot equal 1/3 either. Okay? Now, I do have some common factors. So I've got a common factor of 2. And then I've got 2 x's here and 1 here. So one of these will cancel with this. And there's going to be 1 left in the numerator. And that's my answer, basically. X times 2x plus 9 over 3x minus 1. And someone pointed out to me that in the key, I forgot to write the denominator in. There we go.
2x minus 9.
Oh, minus. Thank you. Okay? So
Is it 2x? Yeah.
okay. So if we look at the very first step compared to our first step, then we can already see where the error is, right? Now, I got to warn you, though, sometimes the first step might be correct and your first step might be correct, and there may be more than one way of approaching a problem, right? So you kind of got to be careful for that. And what I always tell people to do is compare this step to the one that came before it. If they are not equivalent, that's where the mistake is. So equality should hold through, right? So if I look at this, this is not equivalent to the original expression. So the mistake is here, right? And this should be 2x times 3x minus 1. Okay. Now there are more mistakes. So for example, I can see in the next step, they canceled 2x squared with 2x's. That's not right either, because you have to cancel, there'd be an x left in the numerator, right? And then if you keep going further, it looks like they canceled 2x with 3x. So there's mistakes all over the place. And then also, and hint, hint, sometimes there can be mistakes just in the non-permissibles. Sometimes that's where the mistake lies. So, it's up to you how you want to do it. Some people, and again, with some problems, sometimes the mistake is very obvious. But make sure even if it's just find the mistake, go through it yourself as well, to make sure that you are correct. Okay? So there's a couple of these for you to try on the next page, and we're almost done here. I'm going to pause this again. Okay, so this is the last thing we're going to talk about. Just a reminder, though, we are going to come back to these in sort of May, around May. And what we're actually going to do with these, we're looking at the simplification process of these rational expressions right now. And so if you think back to fractions, you maybe started doing that at a very young age, and you essentially were simplifying fractions, right? So 5/10 equals 1/2, that sort of thing. That's what we're doing with rational expressions right now, okay? What we're going to do in May when we revisit them is we are going to learn how to add, subtract, multiply, and divide rational expressions. That's one thing. And we're also going to learn how to solve an equation that involves a rational expression. Okay, so that's kind of where we're going, but we're going to come back to this after. Okay, so here's another example. The simplified form of a rational expression is 2 over x, where x cannot equal -1 or 0. Determine an equivalent rational expression.
Why can't x equal -1?
Okay, so here's the thing. This is simplified. So we're kind of working backwards here. This used to be something else, and then that something else got simplified, and this is what was left. Okay, now the original expression had these non-permissible values. So if x cannot equal 0, what would you have to see in the denominator to create that non-permissible value? What factor would you have to see in the denominator? I heard someone say it. Yeah, x. You'd have to have a factor of x in the denominator. Okay? If x cannot equal -1, what factor in the denominator would lead to a non-permissible value of x not equaling -1? Yeah. Not 1, almost. Yeah. X plus 1. You'd have to have a factor of x plus 1 in the denominator. I'm just going to abbreviate that. Okay? So let's take a look at this. This is what is left once this thing has been simplified. And let's check this against the factors that we have to see in our denominator. So we need a factor of x in the denominator. Do we have that?
Yes.
Yep, that's already there. So this is good. We also need a factor of x plus 1 in the denominator. Do we have that? No. So what must have happened is that a factor of x plus 1 must have canceled, meaning that there must have been 1 in the denominator and in the numerator. And that's our equivalent rational expression. Okay, let's try another one. Okay, the simplified form of a rational expression is x minus 1 over x plus 2, where x cannot equal -2, 0, and 1. Determine an equivalent rational expression. So let's work with this. If x cannot equal -2, this is sort of what we want to see in our denominator. What do we need to see in our denominator? Yep, x plus 2, that's right. Okay, if x cannot equal 0, what do we need to see in our denominator? X. And if x cannot equal 1, what do we need to see in our denominator? X minus 1. Okay, so if I'm looking at this, right now I have x minus 1 over x plus 2. Okay, now if I look at the factors that I need to see, I've already got this one. And remember, I want to see these factors in my denominator, because the factors in the denominator are what lead to non-permissible values, okay? I do not have a factor of x in my denominator, so I'm going to add 1 in the numerator and the denominator, because that would have canceled in the simplification process. And then I'm also missing a factor of x minus 1 in my denominator.
Wait, why did you add the x there? Sorry, I know you.
So this factor is because of the non-permissible value of 0.
But you already.
This is all I have in my denominator right now.
X plus 2. Okay.
Yeah. Okay. Now, if this was a written response question, that would be absolutely fine. Okay. But I want to show you what it would look like for a multiple choice question, which I think would probably be more likely. In a multiple choice question, what you would see is that the monomial factors would come at the beginning. So this guy would come over here. And then also if you have repeated factors, you'd see that in exponential form. So it would be x times x minus 1 squared over x times x plus 2 times x minus 1. Okay? So if you gave an answer of the first thing, that's fine. But you need to recognize that this and this are equivalent. Okay? Any questions with that? All right, so I want you to finish these questions, and that's all we're going to do.